Okay, so we're going to do this problem first. A class has 5 students. What's the probability that at most 3 of the students were born on a weekend? At most, 3 of the students were born on a weekend. Well, the first thing you need to know is that the probability of being born on a weekend is 2 out of 7, and the probability of being born on a weekday is 5 out of 7. And if we conduct that experiment 5 times, we have 5 different students, that's going to represent the probability of all of the different possible outcomes. The probability that at most 3 of the students were born on a weekend, well, that would be this one here. That would be probability that none of them was born on a weekend. That would be C50, 5/7 to the 5th. Probability that one of them was born on the weekend would be 5/7 to the 4th times 2/7 to the 1st. Possibility that 2 of them were born on a weekend. 5 choose 2. 5/7 to the 3rd. 2/7 squared. And the probability that 3 were born on the weekend is 5 choose 3. 5 to the 7th squared times 2 to the 7th to the 3rd. Now, if you're working without a calculator, you can stop there. If you're working with a calculator, or if you want to keep going anyway, 1, 5, 10, 10. Okay. This is the probability that no one was born on the weekend. And this is 5 to the 5th. $31.25 over 7 to the 5th plus 5 times 5 to the 4th times 2. So that's 1250 over 7 to the 5th plus 10 times 125 times 4 over 7 to the 5th plus 10 times 25 times 8 over 7 to the 5th. This is 3125 plus 0, 5, 1, 6, 0. Carry the 2, 2, 6, 2, 5, 0. Plus, this is 500, so this will be 5,000. Plus, 25 times 8 is 200 times 10 is 2,000. So, all of that is over 7 to the 5th. This is 375, 9, 11, 16, 375 divided by 7 to the 5th, which is 16,807. 97.4296, and that is what we were looking for. So that's that one. And number 4 Jar contains 7 black buttons and 7 brown buttons. Okay. 8 buttons are picked at random. So 7 and 7 is 14. We're going to choose 8 out of the 14, and at most 5 of them are black. Well, you can't have 0 black buttons because we're going to choose 8 of them. There are 7 black, 7 brown, so you're going to have at least 1 black. Here we go. There are 7 black and 7 brown. So you'll have at least 1 black and then 7 brown. You might have 2 black and 5 brown. You might have 3 black and 4 brown. Is that right? No, this would be 6. 6. This would be 5. There we go. We wanted to add up to 8. 4 black and 4 brown. And again, we're doing at most 5 of them. So there might be 5 black, in which case there would be 3 brown. And in each of these cases, we're choosing out of 7. So this is 7, choose 1. This is 7, choose 2. 7, choose 3. 7, choose 4. And 7, choose 5. That's what we're doing with the blacks. With the browns, it's 7, choose 7. 7, choose 6. 7, choose 5. 7, choose 4, and 7, choose 3. Now, just quickly going through this. 1, 7, 21, 35, 35, 21, 7, 1. So here are our numbers. 7, choose 1 is 7. 7, choose 7 is 1. 7, choose 2 is 21. 7, choose 6 is 7. 7, choose 3 is 35. 7, choose 5 is 21. 7, choose 4 is 0, 1, 2, 3, 4, 35 times 35. And 7, choose 5 times 7, choose 3, that's going to be 21 times 35. So let's figure out what that is. This is 7, 147. Let's just do this way. 35 times 21. 735 here, 735 here, and 35 squared is 1225. And so that is 14, 19, 24, 29. And this is 2, 10, 4. That's 10. That's 18. 2849. So that's how many different ways there are to get at least, or at most, 5 black buttons. And how many ways are there to choose 8 buttons out of 14? It would be 14, choose 8. What does that look like? 14, 13, 12, 11, 10, 9, 8, 1, 2, 3, 4, 5, 6, 7, 8, divided by 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. The 8s and the 7s go away there and there. The 6 and the 2 can go away here. This way, 4. Okay, so I've got 2 times 5, we'll get rid of that. Guess 3 over here, we'll get rid of that. And this will get rid of that. So what I have is 7 times 13 times 11 times 3. That's going to be my denominator. 13 times 11 times 7 times 3. That's 3003. So 2849 over 3003 is 94.87179 something 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 percent. Hey, it worked out.